Thank you. Thomas Lynch. I had already introduced him. I will introduce him once again. He will be speaking about common mistakes when troubleshooting IP networks. So, the floor is yours, Thomas. And Ellie is monitoring the time. We will show you a shoe on your head if you don't finish on time. Thank you, Thomas. I will start with a question. How many of you use ping every day? How many use traceroute? Good. How many measure latency using traceroute? So for those of you who raise your hand, this presentation is addressed to you. So let us now speak about errors in troubleshooting in IP networks. It is important to understand the limitations of these tools, ping, traceroute, and MTR. You might be asking yourselves, why do we speak about ping, traceroute, and MTR in 2025 when the ping dates back to 1983, traceroute 1987. So these are excellent tools. However, we have to learn how to use these. And once again, why do we need to have a presentation on this? We all know this works. Now, why? This is because a couple of days ago, doing some troubleshooting, I asked where you were sending your ping from, and I said, from my laptop. The other person said, from my laptop. So the different options is from my aunt's house, from the company, from the data center, from a virtual machine. There are infinite types of responses. And another typical case was that very recently, someone was complaining about the latency and packet loss. And they showed me a Grafana that was incredible with lights and colors and errors and bars and graphs that went up and down. I said, how can you see that latency? And he said, I'm reading this with traceroute. And when he said, I'm reading this with traceroute, I did like this. I'm reading it with traceroute, and we note that the third hop has 100% of packet loss. So these tools can help us very much, but can also be quite confusing. Many of these confusions are because we don't fully understand the internet as asymmetrical paths. What goes in one direction not necessarily comes back along the same path. There are hops that you might have seen with MPLS. That is a typical case. Overestimating the meaning of intermediate hop latency and also the false alarms that are triggered by ICMP rate limiting. Which are the common mistakes with ping? To assume that packet loss is equal to a down host, and that is not the case. It can be filtering ICMP. And latency, maybe this is the most important part. I was speaking with Ariel Weher not so long ago on how to measure latency. So I can measure latency with ICMP, but in fact I am using a different application. I can use telephone application or HTTPS. So prioritization of ICMP with respect to the other protocols is different. And once again, state the source origin, IP origin. It's an IP address. It's not my home. Why is it important to state the source address? In a server, I do ping from server 1 to server 2. I have these two IP addresses, origin and destination. Now, in a router, I write ping 2001 DB8::1. And we never really know which origin IP is using, if the loopback is being used, if the interface address is being used, or a decision algorithm that the router has in order to select the origin address. So it's always important to state the origin address. From the common mistakes with restart on these, I could write a whole book. So let me summarize these. Along my experience, I've come across so many things. One of the most strange mistakes is that CH is not equal to CL. Many people assume that CH, I have Hugo over there, CH was the domain of Chile, the domain name. CL is the domain name for Chile, and CH is for Switzerland. So there were errors. For example, naming a router the .ch because it was in Chile, and people said, well, all the traffic was going to Switzerland to then go to Miami. So it left Santiago, Chile, it went to Switzerland, and then went to Miami with a latency that was just Miami, Santiago. Another common mistake are the asymmetrical paths. This is in traceroute. The asymmetric paths are something that we should bear in mind. This is very important. A ping test could not be only from origin to destination. We also have to follow the destination back to the origin. There are also major differences. Windows uses ICMP and Linux uses UDP. If anyone wishes to correct me, please do so. But so far it has been like that. Then, common mistakes with traceroute. These are responses that I have received from troubleshooting. The first hop rules out everything. Now, these are somehow regenerated in a strange way, and then we have the second and the third one. The maximum latency is 261 milliseconds because one of the lines responds 261 milliseconds, and the last one, which is covered over here, is packet loss. Packet loss is 100%. So I could finish my presentation here and say, don't measure. Don't measure packet loss and don't measure latency with traceroute. You can use traceroute for something different. Traceroute allows you to know the path from point A to point B, and from point B back to point A. MTR. How many of you are familiar with MTR? How many of you use MTR? So I was quite surprised to see that a friend of mine who graduated many years ago asked me a month ago if I used MTR, and he's been working in network traffic for many, many years. Now, MTR brings the best of traceroute with the best of ping and enters this into a result. Once again, these results can lead us to misinterpretations, particularly with asymmetric paths. Here I'm doing ping with two NL-NOG ring nodes. One is from NOG Brazil and one is from my company. And we can see here from NIC PR towards my enterprise, it follows one path. There's a packet loss of 100% in the second last. And from my virtual machine to the virtual machine of NICVR, it follows a different path. Now, basically, this tool is not very well known, but since 1996, it's 30 years old almost. And I was quite surprised to see that this person told me that he didn't know this tool. It works with Windows, it works with Unix, and it should be in Linux. You have to install it, and that's it. But once again, this is just to highlight the asymmetric paths in the internet. For example, doing ECMP troubleshooting that you have in BGP. So when you have an equal cost multipath, the router does flow balancing. There is also packet balancing, but here you can see how two different flows, because they have two different origin addresses, they change the path. One has 4 hops and the other has 5 hops. So that is balancing. Host 1 does not control that. This is controlled by R1. That is why you not only have to keep one ping, one traceroute, or one MTR, you have to do several pings and use the MTR to use different UDP ports or whatever. Best practices for this are to use multiple tools for establishing correlations. It's very important to do data correlation. When we do troubleshooting, we cannot just keep a ping with 10 packets and say there is a lot of latency. Another best practice is to analyze trends over time. So if you're having an issue, just one ping, just one trace route won't be enough. And then to learn the prioritization policies of the devices through which we are using when we do this. By default, some rule out ICMP, others allow this to go through, others put rate limits, and with others I can have a firewall policy in order to filter that ICMP or establish a rate limit of 1 mega per second. That is something that Douglas loves to do.
Beyond the pings and R, and there are many tools around, and Ariel was asking me, why are you going to give that presentation? And the truth is that, yes, okay, many of us work in an underworld where we already know that this is used or that is used and all that sort of thing, but usually the community is not alert about all these tools. So what I'd like to highlight here is fping, that can send pings to many IP numbers at the same time. BGP alerter, that Maximo Candela is here, and that's a key tool. RIP Atlas, I don't know whether Michaela is still there with that project, and also to bring this reference of the ring N long LNL nog. These are virtual machines similar to RIP Atlas, and even the virtual machines of Ring have this RIP Atlas installed in it. So rather than using the machines, using more than one tool. The conclusion, well, we've already seen the conclusions, but in my view, the most important conclusion is that we need to understand how the network behaves with time, as time goes by. We can't measure a network with a single ping and a 3 route. Any questions? I have a question. Douglas, maybe just to complement, I am Douglas. Those that operate the networks and that measure the inbound flow of the packets that come into the networks. Recently, it's ridiculous to see the amount of robots doing ping locally. Apparently, we have many more ping packets that really exist. It's a hyper, but it's exaggerated. But I think that tool should be used only as needed. And I think it has to do with AI, that there's a proliferation of pings everywhere, and the pings of our routers are suffering. I don't know whether you can make some comment about it. Well, yes, indeed. That is, if you start analyzing the traffic of the router, you will have SMP packets that may be even more than the traffic packets. I think that we have an overdose of pings. You're right. But however, sometimes you really need to measure a certain number of points for a certain time. But sending pings to all the IPs possible, all the countries possible, is absolutely not necessary. I absolutely agree with you. You, the young man. Hello, Thomas. That was a very nice presentation. I have your coffee here. Thank you. I wanted to hear your feedback to see whether we can transmit any messages based on this. What do you think of measuring whether the internet works? I'm going to say it in IPv4. What do you think of measuring the function of the internet based on quadruple 8 or quadruple 1? Oh, that's terrible. Because I have many acquaintances that say the internet is not working right because yesterday it was 10 milliseconds. Today I have 40 and now I have 40. That is, well, what we have to understand with those IP addresses, the open DNS, quadruple 8, quadruple 1, quadruple 9, you even lose it's that they are anycast. So maybe one day the network that is working with Anycast exclusively is not working right, or they are using another transit provider, or they are sending their traffic through the IXP, or they are sending the traffic because a link got saturated. So you have those differences in latency. There is it's not free, but it's called DNS-Perf. It's a website that shows you the charts of the different DNSs that are open. But it's an error, indeed. It's a mistake to say today my network is more slow because yesterday it was with 10 milliseconds and now it's 14 milliseconds. Sometimes the other one is to blame. And then we go back to discuss the asymmetric paths of the internet. We have time for the last question. Andres was there. So then you can ask Tomas. Good morning. I didn't clearly understand when you just mentioned, when you were talking about how to the prioritization in the network or in the OSS, the way they treat the packets. No, I was talking about the network. Usually They give a greater priority depending on the networks that you're connected to. You're going to give, for instance, more priority to the voice traffic. Yes, that's usually when the operative systems are more overloaded. So they may create a false positive. Yes, a false positive in the same server. Yes, yes, absolutely right. That's possible. Thank you. So, a round of applause for Thomas Lynch. And now the last present.